Just last week, a supply chain attack compromised critical AI development tools, attempting to steal sensitive data. This came just after a stark warning from the UK government about the dangers of vibe coding. But what exactly is vibe coding, and how are AI tools simultaneously revolutionizing how developers work, while also opening up new, serious security vulnerabilities? Let's dive in. Today's developer tools are making a clear shift towards conversational AI. Imagine telling a bot what you want, and it just writes the code. Tools like Mission Control do exactly this, turning natural language into executable code with minimal friction. But it's not just simple automation. Autonomous AI agents are becoming incredibly reliable in continuous integration pipelines. For instance, Claude's self-healing AI pipeline resolves an astonishing 94% of failures without any human help. A huge leap forward is the persistence of context. Developers are now equipping AI agents with memory, often backed by SQLite and knowledge graphs. This means tools like Claude Code remember information across different interactions, making them much smarter over time. This is greatly enhanced by improvements in vector search. The SQLite extension, for example, allows SQLite to perform similarity queries directly, often eliminating the need for separate, external vector databases in many AI applications. The concept of agentic AI systems, those that set their own goals and adapt based on feedback, is rapidly moving from theory to practice. It's truly impressive what compact codebases can now achieve, like a SaaS AI assistant built in roughly 90 lines of TypeScript. Now, let's talk DevOps. Major platforms continue to offer generous free tiers. GitHub, for example, provides 2,000 free CI/CD minutes every month, which many teams wisely allocate to critical testing and deployment workflows. However, a recurring problem is invisible drift in monitoring stacks. Subtle configuration changes accumulate unnoticed, leading to failures that are incredibly difficult to trace. That's why regular audits of your monitoring tools are absolutely essential. A new frontier is the expansion of MCP, or Model Context Protocol servers. These are enriching the toolkit for AI-assisted operations, acting as central hubs for AI assistants to access various tools and functions. Take PayPal's official first-party MCP server. It grants AI assistants access to over 30 tools covering everything from invoicing and payments to subscriptions and even shipment tracking. In a different domain, PagerDuty's MCP server offers over 60 tools for managing the entire incident lifecycle, from creation and resolution to on-call scheduling. These are powerful integrations. And when Docker builds fail, which they sometimes do, Context Zip helps. It retains only the relevant build context, cutting through the noise that can obscure root cause analysis for AI-driven troubleshooting. But let's come back to security. The incident where LiteLLM versions 1.82.7 and 1.82.8 on PyPI were compromised to exfiltrate environment variables is a stark reminder. Dependency-level threats are on the rise. The UK National Cybersecurity Centre's warning about vibe coding is critical here. They argue it introduces intolerable risks, urging AI coding tools to be designed specifically to avoid introducing new vulnerabilities into our systems. On a more positive note, platform-level services continue to expand resources for developers. HarmonyOS offers multiple network request frameworks, and OpenMedia provides a free weather API with no keys or rate limits for non-commercial use. These examples show the dual nature of AI in development. It's a powerful accelerant, creating new efficiencies and capabilities we've only dreamed of. But it also demands a heightened sense of vigilance. The future of AI-augmented development is bright, but only if we rigorously prioritize security, ensuring innovation doesn't outpace our ability to protect it.